Welcome back. In the past 2 weeks, we investigated options to make buildings more energy efficient and carbon neutral. For example, by making changes to the building envelope, using more efficient installations to produce heating and cooling, switching to low or zero carbon energy sources, and switching to more efficient electrical equipment and lighting. But when buildings are not built as planned, insulation measures are improperly applied, installations are not correctly installed, and residents do not know how to use appliances and new equipment like heat pumps, then still a lot of energy gets lost. Research shows, for example, that even in the most modern utility buildings, 10 to 30% of energy is wasted due to malfunctioning installations and unexpected user behavior. Besides, comfort levels are not what they should be, with sometimes serious issues like high indoor CO2 concentrations. Developments in digitization, however, provide opportunities to mitigate this energy wastage. In the first place, more and more data become available, as shown in this picture through installed smart meters, building management systems in large non-residential buildings, application of sensors, smart thermostats, and in-home displays. In addition, developments in artificial intelligence and machine learning methods provide the means to utilize these data to make buildings smarter energy users. Let's investigate 2 examples to get a picture of the potential to achieve energy savings by smart use of data. First, an example on how data collected with a smart in-home device are used to detect energy wastage with appliances. This picture shows the power demand for a typical household in the Netherlands for one day. On the horizontal axis, the local time is displayed, and on the vertical axis, the power demand in watt. The blue line are the electricity consumption data that are extracted from the smart meter at 10-second intervals. As appliances all have different load patterns, and by using data from a very large group of households, the company offering this smart in-home device was able to train an algorithm which can detect the different appliances when fed with 10-second electricity data. In this way, the washing machine in green, dryer in grey, and the dishwasher in pink can be detected. Next, the electricity usage of these appliances is compared with consumption of industry standards and the data of peers. Finally, this is translated into a personalized advice like, it looks like you often wash at high temperatures. Your dishwasher needs more energy to heat the water. Washing at eco modes gets your utensils just as clean. The company offering this service learned that over 40% of household appliances are inefficient or being used inefficiently. Now let's investigate an example for non-residential buildings. In most existing utility buildings, it is common practice that heating, ventilation and air conditioning systems are turned on at 7 in the morning and turned down again at 6 in the evening. The systems don't anticipate actual presence or actual weather conditions. Predictive control of the heating, ventilation and air conditioning system, short HVAC systems, is a way to steer towards smarter energy control and energy savings. In this case, from data from the smart meter, a building management system, available sensors and information on zone heating are collected in real time. These data are combined with external data such as weather forecast data. Information of all these sources is combined and algorithms can be trained to anticipate actual thermal needs in the building. Next, this algorithm is implemented and sends comments to the HVAC equipment on the capacity that needs to be delivered each point in time. In existing office buildings, energy savings up to 50% can be realized. We can conclude that there is a huge, still largely untapped potential to realize energy savings in buildings through smarter use of available data. We have already seen that smart lighting, making use of presence and daylight detection, can save up to 60%. Also, smart connected appliances have the potential to save up to 60%. According to the IEA, digitization could cut total energy demand in residential and commercial buildings between 2017 and 2014 by as much as 10%, and that about 60% of this potential can be realized with non-residential buildings. Thank you for watching this video. In the last video of this week, we will look into the impact of government policies aimed at reducing energy demand in buildings.